In this video, I'll be talking about our DIY home solar setup. I'll also differentiate the three types of solar installation for you to know which one is really best suited for your own home. I will then show you the components of our home solar setup, and I will give you an idea about the cost involved with this project and weigh in if it's really worth it or not. Before I'm going to show you the components hidden behind these walls, let me tell you a bit of history about this solar project. This technology is relatively new in the Philippines, and the components can only be purchased online or of course through local resellers in major cities, thus adding to the cost of procurement since you will be the one to shoulder for the shipping charges. Like most of you living in the countryside, having a reliable water supply seems to be very impossible. That's why we installed a water pump to ensure a steady supply of water in the house 24/7. Unfortunately, during power interruption, we don't have water as well, and what a shame to live in a smart home but don't even have water, which is pretty basic, right? Few solar installation companies nearby are ready to put up this kind of project, but the costs are too high. With the help of Google and YouTube, I actually studied everything, and since I'm not a physicist nor an electrical engineer, this is totally a whole new world for me. Luckily, I have someone who helped me throughout this project. Papa did not only design this house, he's also the one who did the electrical installations by himself. Now let me show you our old setup using only 100 ampere hour battery, 10 amps solar charge controller, a manual transfer switch, and 3x100 solar panels. I will be explaining each of this function later in this video, so better keep watching. Initially, the purpose was to provide a backup power for our pump, but later on, we decided to upscale our solar generating capacity to 2.2 kilowatts and currently powering most of the appliances at home except for the heavy loads. Now, I will differentiate the three types of solar setups. The first one is a grid tied, where you essentially use the power generated by your solar panels first and let the power supplied by the electricity provider fill in the remaining energy requirement to run your appliances at home. The main advantage of this setup is that the cost is very minimal since you only have to buy an inverter and solar panels. And this seems to be the cheapest among the three setups. You also need not worry about the power surge coming from your air conditioning units, maybe your refrigerator or your pump, and other inductive loads. The main disadvantage of this setup is that the inverter will not supply power during brownouts. Meaning to say that even if it's 50 degrees outside, when the grid doesn't produce power, you will still be affected by the power interruption. By design, grid-tied inverters have an anti-islanding feature that cuts the power output when it cannot sense power coming from your distribution utility. This is actually done to protect the lineman when your solar power will backfeed to the grid. The next type is the off-grid solar installation, which is actually the one we have here in the house. This setup is ideal if you frequently experience power outages in your area. We experienced a lot of these power interruptions in the past, and that prompted us to go solar. A power generator is a cheap alternative, but very noisy and not environmental friendly. In principle, you store the solar energy first in the battery bank before it gets converted to electricity. In the house, we have a battery bank capacity of 400 ampere hours, but we only use 50% of it to prolong the battery life. Assuming we only use 10 amperes max, so 200 ampere hours divided by 10, we essentially have 20 hours of power in ideal condition. But technology is not yet perfect. We need to factor in the efficiency loss during conversion, which is around 15%. The main disadvantage of this type of setup is the cost of the battery bank. We have 8 times 100 ampere hour battery, and each costs 8,000 on an average. Another disadvantage is the storage power of our heavy loads that cannot be absorbed by the inverter. The split type aircon in the living room, for example, is around 2,000 watts. The heater in one bathroom is close to 5,000 watts, and the multi-point heater for my shower and bathtub is around 8,000 watts. It's no longer practical to invest in bigger capacity inverter and power bank due to its cost. The third type of solar installation is the hybrid, where you use your solar energy first and subsequently store excess power in your battery bank. This will serve as an emergency power source or EPS that can power critical loads such as your lights, fans, router, among others. The main advantage is that the storage power will never be an issue and you will be having a backup power during outages. The main disadvantage is obviously the cost of the hybrid inverter plus the battery bank that could cost even more if you will be using the latest battery, which is the lithium iron phosphate. But if money is not an issue, you can actually buy the Tesla Powerwall 1 that costs around 150,000 pesos, or the version 2 which costs more than 300,000. Now let me show you the components of our solar setup. Come on, follow me. Here in our electrical/utility room where the magic happens. I'm gonna explain the function of each of these devices. Let me start with the solar charge controller. The main function of this device is to regulate the power that's coming in from the solar panels to the battery to maximize its efficiency. It has an undervoltage as well as an overvoltage mechanism that protects the battery from wearing out too easily. It has 3 charging stages where the stage 1 is called the bulk or fast charging when the battery voltage is below 80%. The second stage is referred as the absorption stage when the remaining capacity before it gets full is only 20% or less. The last stage is called floating when the voltage is held constant while the current is reduced to less than 1% of its battery capacity. The SCC will basically stop charging when the battery is full to prevent any damage. The next one is the automatic transfer switch. This serves as a gateway between the solar and the grid power. I set it to transfer to the grid when the battery voltage is less than 24.3%. Around 7 or 8 in the evening, and switch back to solar when the voltage is at 25.5, usually around 7 in the morning. Next are the circuit breakers. This one cuts the power from the solar panel to the battery. The middle circuit breaker cuts the power from the battery to the automatic transfer switch. And the third one cuts the voltage from the battery to the inverter. This massive device is a kilowatt 24 volt low frequency pure sine wave inverter that converts the direct current from the battery bank to an alternating current that is similar to the power supplied by our power distribution utility. It can absorb power up to 6,000 watts, but we're not overstressing this device. It also has a built-in transfer switch, but we're using the standalone ATC since it only transfers the connection from the mains power to solar when the battery is almost full and transfer the power back to the DU even when the battery is still at 70%. You can hear the beeping sound of the inverter when the voltage is low and the load is about to be transferred to distribution utility. This alarm can actually be turned off, but I'm using this as a reminder that the connection is about to be transferred and we need to switch off unused lights or appliances, or else I pay extra for the electricity consumed. The next is the battery bank. Each of this battery has a capacity of 100 ampere hours. We have 8 of this solar battery, which is a gel type, so we're supposed to have 800 ampere hours. But since we have a 24 volt setup, we only have 400 ampere hours, in which only 50% of its stored energy is utilized to maximize its life cycle. Next is the supercapacitor bank. By the way, this is optional. It absorbs sudden energy draw from the battery to prevent early damage. The next is the photovoltaic modules or the solar panels. We're using the monocrystalline type since it only needs light to produce electricity than the polycrystalline ones that need direct sunlight. Fun fact, these solar panels are actually more efficient when the temperature is not too hot. If you think that the hotter the better, well, it doesn't work that way. Out of the 2.2 kilowatt installed capacity, we only enjoy 70 to 80% peak efficiency since the technology is not perfect. We also installed monitoring devices. This one is the digital amp meter that measures the voltage, the watt power, and current energy drawn from the inverter. This is the Wi-Fi module called the GSP Cloud. It provides real-time information such as the power produced by the panels, state of charge, as well as the battery voltage, among others, as long as I'm connected to the internet. I'm not going to discuss the cost of each of these devices for now, but the total cost of this project is around 150,000 pesos. I used to pay 4,000 to 5,000 pesos per month for electricity, but now we're averaging around 1,500. Assuming I can save 2,000 pesos per month, the total cost of the equipment will be paid off in 6 years. It doesn't mean I will enjoy free power after that. Remember that these solar components are on 24/7. The battery bank, for example, has a lifespan of 5 to 8 years depending on the brand and usage. The inverter may work up to 5 years or more, and only the PVs or the solar panels could last up to 25 years. To be honest, having a solar setup at home feels like I am only paying our electricity bills in advance since I still need to think about the natural wear and tear of the solar equipment that could happen sooner or later. However, it gives us a sense of convenience during power outages, especially at night, since we have enough power to run our critical loads like lights and fans until the sun shines. I can also turn on my AC without having to worry about the bill, especially now that I'm staying at home most of the time due to this pandemic. If you really want to go solar, I would suggest you start with a small setup first until you have the budget and confidence to upscale your generating capacity. If the power supplied by your electric company is stable enough, go for the grid tied, then just add a battery bank later on. Just a word of advice, if you really want to go with the DIY path like I did, make sure to study everything or ask someone else who knows about electricity for your safety. Remember, you should be extra careful when dealing with electricity or else it will hurt you and even damage your property. We're using solar for barely 3 years now and I keep on learning new things since the technology is fast evolving. If you guys are really interested, I'll be making a basic setup tutorial in my future video. That's all I have to say for now. I hope you learned something today, and if this video is anything of value, please hit the like button and subscribe if you're new to my channel. If you have any questions or suggestions, write it in the comment section below and I will try to answer them as soon as I can. Thank you so much for watching and keep safe.